Next, we'd like to welcome Dr. Mark White, who plays a huge role in our packaging department here at Virginia Tech. He's also the former director of the Center of Packaging and Unit Design here, and he's just going to say a few words about our program.
Yeah, can we start? There you go. Welcome. I've been asked to give you a history or background of the development of packaging science here at Virginia Tech. Why? Because I was here at the beginning. I'm going to make this brief. But to paraphrase what I'm going to do here is, we have very fine academic institutions represented here, many packaging schools, and you all know yourselves. When we developed this packaging program, as you can tell, there was no reason for us to replicate what other institutions are already doing and doing extremely well. You're going to see we took a little bit different approach, and I'm going to try to explain why. Create a little bit of a different individual than many of you do. I am not saying this is better. What I'm saying is it's a little bit different, and I hope you find it interesting. Okay? Let me begin by saying that our history goes back quite far, but with regard to the packaging science programs in the country, we're the new kid on the block, so to speak. So I want to briefly go through and show you the evolution here, if I can, and maybe I can't. Do I have control? See if you can work it out, Zach. Anyway, let me share with you that believe it or not, packaging science at Virginia Tech goes back to the 1950s. A gentleman by the name of E. George Stern, who was an architect, is working at the university in the engineering program. And what's this guy doing? His whole life was dedicated to nails. He wrote the definition of the nail in Webster's dictionary, okay? And you go, wait a minute, what does that have to do with packaging? Well, I'll try to make the connection. And the connection is that this National Wooden Pallet and Container Association, consortium of small family-owned businesses around this country, right now maybe 3,000 of these vendors of wood pallets. Well, what's a pallet made out of? Wood and nails. They came to George Stern and said, can you help us make a better mousetrap? Believe it or not, a better wood pallet. And George set apart doing that. In fact, in 1976, he convinced the pallet industry to give this university a nice chunk of change to build the William H. Sardo Jr. Pallet and Container Research Laboratory, which probably is still unique in the world. It's going to be fascinating, all of you, as you go out into your careers. They're going to ask you, what did you do? What did you study? And you're going to say packaging, and they're going to look at you and say, packaging? You know, they've never heard of it. And then you explain to them that everything's packaged. And then they go, oh, well, consider this poor guy. They're asking me, what do? I do pallets. And they look at me and they say, you've got to be kidding. And then I say, we have a laboratory dedicated to pallets. And it blows their mind. They say, you've got to be kidding. We deal with the thing that's taken for granted, folks. It's fascinating. But it's something that when somebody tells you, I've never heard of it, you need to be proud of. Because that makes you very, very unique. So you can see where we started. We started in the world of pallets, which is part of our supply chain. As I explain to everybody, when they say, you're kidding, pallets? Everything moves on pallets. And then they go, oh yeah, okay, they're kind of important. You know, they don't get it at first, but then they get it. And that's where we came from. In 1979, I took over directorship of what was then the Pallet and Container Research Laboratory. And I traveled the world because this was the only laboratory in the world that did pallets, if you can believe it. And that was our origin into this discipline of packaging. You're probably going to have to move that forward, Zach. Okay. In terms of our evolution, in 1993, I took the Pallet Lab and I expanded our mission to the Center for Unit Load Design. What I meant was we now brought in distribution packaging into our research programs and the design and performance of distribution packaging, as well as the design and performance of pallets. But we also brought into our program research about how forklifts conveyors, trucks, all of those materials handling equipment interact with the pallet and interact with the packaging. So we expanded our mission. That's all we did in 1993. Bear in mind, up till now, we're just doing research. We do not have an academic study program. In 2006, we established this study option, packaging science option. In the fall of 2006, we had 4 students declare in this option, which was a subset of the department activity. Okay? That was the beginning of the packaging science program at Virginia Tech. In 2010, we hired Dr. Kim, Dr. Horvath, and Dr. Bush moved into packaging science. I retired from the program in 2007 and started another career, but that's a whole different story. But anyway, these 3 new faculty came in and they have built the program from our first class of 4 students up to what we have now is an enrollment level of about 50. And in 2013, we were authorized through the State Council of Higher Education in the state of Virginia to go ahead and offer a degree major in packaging science. That was a huge leap for us. You need to understand that we have a very strong master's program and a very strong PhD program. And our focus up until 2006 was universities have 2 products. Universities manufacture 2 products. If you look at it from a corporate point of view, product number 1 is we put out information. Our research program puts out information. Product number 2 are young educated professionals. That's the other product that universities put out. And it wasn't until 2006 in that first class that we started the education process of young professionals. But I want to emphasize we still have a strong program in research. Zach, go ahead. Our research activities, and this is a very strong incentive here in the university, correspond to our faculty interests. My interest is research interest number 1. Go back, Zach. You're moving too quickly for me, Zach. It is modeling how forklifts interact with pallets, interact with packaging. That's what we do here, is we study those mechanical interactions and we develop mathematical models that emulate those interactions, which will help all of you in optimizing supply chain efficiency. Research discipline number 2, Dr. Kim's specialty, is looking at the application of bioplastics to food packaging. It's an area I'm not knowledgeable in, but it is an area that's integral to our packaging science research program. And then Dr. Bush's specialty is the whole arena of marketing and market research and business, the business aspect of packaging that we encourage our students to become involved in, interdisciplinary across campus in the business management program. Zach, go ahead. What we've done is, you're going too fast, Zach, is try to educate our students from a curriculum point of view, focusing on the interaction between these 3 components. Now, this is where we start to deviate a little bit from a lot of the other packaging science programs here, and I want to show you how. Next slide, please. Very dark picture, but we have to acknowledge that most all consumer and industrial products move through supply chains in unit load form. And what's a unit load? It is packaged product sitting on top of some platform like a pallet. Yes, UPS is great in parcel, and FedEx is great in parcel, and that's part of the supply chain. But the front end of the supply chain is unitized. And with respect to the Costcos of the world, the entire supply chain is unitized. So this thing is what we really wanted to understand. How does this unit load work? How does the pallet, the packaging, and the trailers that are moving down the road, and the road interfaces, and the forklifts, and the conveyors, and the racking systems, how do those interact? And that's been our focus from a research point of view, and we have built it into our academic program. Our students take courses in warehouse design. They understand SKU velocity and SKU availability and pick face availability, and they understand the design of all of the handling equipment within that curriculum. Why? It's an important component to the supply chain, not traditional part of packaging curriculum. Next slide. If you break down your unit loads, go ahead again, and one more. If you break down your unit loads and you look at the cost of the packaging, it's really fascinating. The packaging on top of the pallet is an order of magnitude more expensive than the pallet itself. Pallet's $9, but empty plastic bottles are $300 to $400 on top. Plastic pails are $300 to $400. So the spend of the packaging on top of the pallet is an order of magnitude more than the pallet or the stretch film. So where is our opportunity to save money? It's in that distribution packaging, which all of you study in great detail in your academic curriculum, and it's extremely important. What's neat is, you know, if we change that pallet, we can change the stress on the packaging. Why? All of the mechanical stresses to which packaged product is imposed in the unit load portion of the supply chain, guess where they go? They go through this pallet before they get to the packaged product. Well, if that's the case, if we start playing around with the pallet, maybe we can reduce the stress on the packaging. If that's the case, then look at these numbers. We have huge opportunities to change packaging spend. And that's been our focus. That's why our students learn pallet design, if you can believe it. And they learn equipment design. And they learn, of course, the packaging design itself. Next slide. Breaking down these supply chains, you've got three basic components. The packaged product. The conveyor there represents all equipment to move unit loads. And guess what's in the middle? This pallet. The pallet is the interface. The pallet is the interface between the packaged product, which we want to protect, and all the equipment that does what? Does all the damage. So our thought process here, we said, well, then let's change the pallet to better protect the packaged product and achieve the opportunities that come out of that. So you can see our thrust here. I hope you see it as you all are moving through your academic program. We're not saying that this is the way everyone should be educated in this discipline. It's just a different approach that we try to take. Why? We don't want to replicate what your programs are already doing very well. That's a redundancy that's not necessary. We just take a little bit different approach in both our bachelor, master's, and PhD level of education. Here's the problem, guys. Right now, in our global supply chains, we've got 8 to 18% avoidable spend in packaging on top of the pallet. How come? Well, it's because we got three different designers out there. We have the designer of the plastic bottle, the designer of the corrugated container, and then we have a separate designer that designs the pallet, and then we have yet another designer that designs the equipment. And what's going on? The vendor supplier is doing the design. And let me tell you, that bottle guy's not talking to the pallet guy, and that pallet guy's not talking to the equipment guy. So what do we have? We have a system of interacting components, and guess how we design it? One component at a time. It's the wrong way to do it. It's the wrong way to do it. We have design communities that don't communicate, and there are various reasons why they don't. One of it is purchasing is putting cost and price pressure on every component. And so that designer is reducing the cost of their component because they're in a competitive environment and they want the contract, right? And they're focused. They're focused on pulling cost out of their component. They don't realize when they do that and ignore the pallet or ignore the equipment, we end up with systems that sometimes don't work, but all systems today that have avoidable cost built into them. Why? These design communities don't interact. So you can see where we're trying to go here. We're trying to get our students to understand the importance of how these components interact, to understand that technology, and to cross over the disciplines. Literally, somebody who understands conveyor design, pallet design, and package design. Because it's then we can move to systems-based design of a system. Next slide. This is a classic example. I apologize, it's a little bit dark, but you've got plastic bottles, 32-ounce bottles of oil inside a corrugated container. And if you notice, that piece of wood underneath is sagging. See the sag in that? Well, the bottle designer assumed the stress on that bottle was going to be the same for all bottles. And I guarantee you, that bottle that is farthest there is supporting much more of the compressive load than the bottle that's closest to me. Did the bottle designer anticipate that? Probably not. The consequence would be leakers. Next slide. In fact, when you look inside, the bottle all the way over, the neck has collapsed. Is the oil damaged? No. But leakers. If that seal is fractured, it becomes a leaker. And then we have a hazmat issue, and it becomes very expensive. Why? It was not anticipated that the pallet designer would design a pallet and the deck board would sag. And the bottle designer didn't anticipate that because they're out there trying to reduce the cost of the bottle. And the pallet designer's not talking to the bottle designer. And the consequence is, next slide. This is an example, again, I apologize, but that's a unit load of antifreeze, and it's leaking all over the place. I mean leaking all over the place. Why? No communication between the rack manufacturer of that drive-in storage rack, the pallet manufacturer, and the package manufacturer. And this is the consequence. You can see where I'm going, guys. Okay, it's all about interactions. Next slide. These are plastic pails. The pail on the bottom to your right is dented, it's collapsed, it's buckled, and the consequence of this is not damage to the contents, and maybe it won't leak. But the next slide shows you that it can be a safety issue. And this is a huge issue. This is the greatest cost of inefficiently designed supply chains. It's human health and injury. And believe me, as a consultant now, I get involved in these litigations all too often. My friends in Home Depot were involved in 5 litigations of death in their stores in a period of 1 year. And those were most often packaging failures. Why? We didn't look at the interactions closely enough, and we had design communities that are working separately and not together. Next slide. Just going to give you one. This is the only lesson here of the history. This is the only lesson of an interaction. This is the reality. Pallets deform when you load product on top of them. And the pallet designer wants it strong enough, but to get it cheap enough, they ignore the fact that it might deform under the load. Oh, it won't break. That pallet won't break. He's done his job. She's done her job to design that pallet. But in order to get a minimal cost pallet, they have sacrificed stiffness in the deck. What's the consequence of that? I already showed you examples. We get stresses wherever those stringers are. Every packaged product over those stringers, let me give you an example. Between those 3 wooden stringers you see there, the compression stress is 0. Over the stringers, the compression stress is 40 psi. As a package designer, if I'm not aware of that, I could make a huge mistake. And I have leakers and failures. So we studied this interaction. Next slide. And this is just a test setup where we measured the compression stress. That little green film you see up there is a pressure sensor. And what you see on the bottom here is a portion of a wood pallet, and on top is a box. It's a simple test, and then we push down. How is it distributed? Next slide. What we found is it's huge. All the red areas you see are in one area of the pallet. The black areas, 0 compression stress. We verified this. The neat thing about this is, if I spend $1 more on the pallet to stiffen the deck, redistribute the load, guess what? I can pull $10 out of distribution packaging sitting on top of it. The net savings, $9. That's a lot of money. Next slide. What we need to do is move from component-based design to systems-based design. This is what we are teaching here at Tech. We're trying to look at this supply chain systematically, look at the components and how they interact, and get these 3 designers who in my previous slide weren't communicating, get them to communicate. Philosophy simple, next slide. Our goal is to create somebody a little bit different, not necessarily any better than the rest of the institutions do here, just a little different. We don't need to replicate what you folks are learning and learning very well at your institutions. We wanted to create a different professional that understands the design and performance relationships of all of these components, and then create tools that these new professionals can use to model how they interact and apply systems-based design to supply chains that are now designed one component at a time. Tools, software. This afternoon, if you get a chance, you're going to see one of those software demonstrated. It's called Best Load. Best Load simulates the equipment, simulates the distribution packaging, and simulates the pallet and unit load supply chains. Okay? And we use it in our program here. It is so much fun to lay out a supply chain to our students and come back and say, optimize it. And to watch the students tweak equipment, tweak pallet design, tweak packaging design to optimize the entire supply chain systematically. It is fun. This particular software demonstrated this afternoon, and I encourage you to participate in that, is available as a free educational license to any of the education students here and to the faculty. RIT is using it in their curriculum. We would like to see the other institutions here use the software. It is a great teaching tool. It is the only tool I'm aware of that models the entire supply chain, unit load supply chain, and how the components mechanically interact. It is a great learning tool. With that, I will sit down and be quiet. Thank you very much for your attention.